So now we're going to do another example where we use U-substitution. So here is our integral, and our first step is to choose a good U. Well, we know that this part smells like chain rule because the derivative of this function has an x in it. So we're going to choose our u to be 1 minus 4x squared. This would mean that our du is equal to negative 8x dx. So our dx is equal to du divided by negative 8 over x. Now we're going to substitute our variables. So we have the square root of u and then multiplied by du divided by negative 8x. The x's cancel out, and we are going to take out the negative 1/8 just to make it a little bit easier, and we're left with u to the power of negative 1/2 du. And if we take the integral of that, we get let's take a test derivative. So 1/2 times 2 is equal to 1, and then 1/2 minus 1 is negative 1/2, which is what we want. So when we substitute our u back in, we get negative 1/8 times 2 times 1 minus 4x squared to the power of 1/2 plus c. Can simplify this a little bit more, and we're left with negative 1/4 square root of 1 minus 4x squared plus c. And that should be our final answer. So once we get more used to taking integrals, many of you will be able to do this type of problem in your head, but it's still useful to use U-sub for functions that become even more complicated.